Automated reasoning checks in Amazon Bedrock Guardrails validate generative AI responses against policies you define, but validation quality depends on how well you write those policies. Manual policy refinement requires effort and expertise that can slow your deployment. With these new workflows, you can improve policies with less manual work. The iterative improvement workflow lets you create natural language tests and automatically deduces the policy changes needed to pass them. The ambiguity reduction workflow refines variable descriptions and type definitions when you encounter unclear translation results. You can access both workflows through the Bedrock APIs or by selecting Refine Policy in the console. These capabilities help you create more reliable guardrail validations by systematically improving your policy definitions. Organizations often need to meet data governance requirements that demand control over encryption keys protecting sensitive user identity data. By default, Amazon Cognito uses AWS-owned keys to encrypt user pool data at rest, but this limits your ability to manage key lifecycle and access policies. With customer-managed keys in AWS KMS, you can now control the encryption keys protecting your Cognito user pool data. You create and manage the key lifecycle and usage permissions directly in AWS KMS, allowing you to define organizational policies and revoke access to encrypted data by disabling or deleting your key. You can configure a customer-managed key when creating a new user pool or update an existing user pool to use one. AWS CloudTrail integration provides visibility into when and how your identity data is accessed through key usage monitoring and auditing. This capability is available in Essentials and Plus tier user pools at no additional cost beyond standard AWS KMS charges, and you can configure it through the AWS Management Console, AWS CLI, or AWS SDKs. Organizations operating multi-account AWS architectures previously could not share Bedrock AgentCore memory resources across account boundaries, limiting centralized memory management and agent deployment flexibility. This feature enables cross-account access to memory resources. You can grant cross-account permissions using resource-based policies attached to your memory resources. Principals and consuming accounts can access memory APIs across accounts via the full ARN to create events, write records, retrieve records, and perform semantic search. You can configure delivery destinations in separate accounts, allowing memory resources to stream events to S3 buckets, SNS topics, and Kinesis data streams located in other accounts. This capability supports building distributed architectures where memory resources and agents span multiple AWS accounts while maintaining centralized control and delivery options. Bioinformatics workflows that generate significant scratch data, such as genomic sequence alignment, BAM sorting, and variant calling, can experience performance bottlenecks and inconsistent runtimes when Scratch I/O competes with shared run storage. You can now use ephemeral storage for private workflows in AWS HealthOmics to address this issue. You get a dedicated local volume mounted at /TMP per task, which isolates Scratch I/O from shared run storage that hosts the working directory. Each task includes 16 GB of ephemeral storage by default at no additional charge. You can scale ephemeral storage up to 3072 GB per task using directives in your WDL, Nextflow, or CWL workflow definition. You enable ephemeral storage using the Start-Run API at runtime. All ephemeral storage volumes are encrypted and automatically deleted when a task terminates, providing faster runtimes and lower costs for your bioinformatics workloads. Migrating self-managed search clusters to cloud environments typically requires weeks of planning and remains error-prone due to the complexity of moving data while maintaining service availability. Migration Assistant for Amazon OpenSearch Service now includes an AI-assisted experience that addresses these challenges. You can use AI tools like Kiro and Claude Code to plan migrations and deploy infrastructure through agent-guided workflows that structure, execute, and validate the process. The assistant automates migration from self-managed Apache Solr, Elasticsearch, or OpenSearch deployments to OpenSearch serverless or managed clusters. You can now capture and replay live Solr traffic, ensuring continuity during migration. The AI-guided workflow helps you handle both historical data migration and live traffic migration, reducing manual effort and errors. Migration Assistant is available in all commercial AWS regions and AWS GovCloud regions where Amazon OpenSearch service operates. Developing and deploying large language models, multimodal generative AI, and spatial computing workloads require substantial GPU memory and high-performance compute resources. You can now use G7e instances in SageMaker Studio notebooks to access up to 8 NVIDIA RTX PRO 6000 Blackwell Server Edition GPUs with 96 GB of memory per GPU. You can utilize GPO Direct peer-to-peer technology to boost performance for multi-GPU workloads, reducing data transfer bottlenecks between GPUs. You can deploy large language models, agentic AI models, multimodal generative AI models, and physical AI models with up to 192 vCPUs and 1,600 gigabits per second EFA networking bandwidth. Multi-GPU instances also support GPO Direct RDMA with FAV4 and EC2 Ultra clusters to reduce latency for small-scale multi-node workloads. G7e instances are available in U.S. East North Virginia, U.S. East Ohio, and U.S. West Oregon regions. Managing logs from network devices and servers typically requires deploying and maintaining collection agents across your infrastructure, creating operational overhead and complexity. CloudWatch Logs now provides managed Syslog ingestion to address this challenge. You can configure firewalls, routers, switches, and Linux servers to send Syslog messages over TCP, TCP plus TLS, or UDP directly to a VPC endpoint in your account without installing agents. The service supports multiple Syslog formats including RFC 5424, RFC 3164, and Cisco FTD/ASA, ensuring compatibility with your existing infrastructure. CloudWatch Logs automatically parses incoming messages and extracts structured fields like facility, severity, hostname, and application name, eliminating the need to build custom parsing pipelines. You can immediately query ingested logs using CloudWatch Logs Analytics to investigate security events or troubleshoot connectivity issues. This capability centralizes infrastructure log visibility and reduces the operational burden of managing log collection across distributed environments. Monitoring Kubernetes clusters requires collecting and correlating infrastructure metrics across nodes, pods, and workloads, which can be complex when using multiple tools and data sources. CloudWatch OTel Container Insights for Amazon EKS addresses this by collecting infrastructure metrics at 30-second granularity, using open-source receivers including cAdvisor, Cube State Metrics, and NVIDIA DCGM. You can correlate metrics across nodes, pods, and workloads in a single PromQL query because each metric carries OpenTelemetry semantic conventions and Kubernetes labels. You can access pre-built dashboards that provide visibility into cluster health, node performance, and pod-level resource usage. You can connect existing Prometheus and Grafana dashboards directly to CloudWatch using the CloudWatch PromQL endpoint. You can enable the feature from the EKS console or via the CloudWatch Observability add-on, Helm, or CloudFormation.